everyone, I am Miss Hu, your physics teacher. In this lesson, we will learn about what mass and weight are, comparing and contrasting mass and weight, as well as calculating mass and weight. This topic is pretty simple, so most of you would already know what mass and weight are. However, I'll just go through this topic so that at least you know your bases are covered for your exams. Let's get right into what mass and weight are. First things first, we need to know the official definitions for mass and weight. The definition for mass is the amount of matter in an object, while weight is the gravitational force acting on an object with mass. Now, as easy as it is to understand mass and weight, these quantities are the ones that students tend to get the most confused about. This is because in daily life, we tend to use the word weight when it's actually mass in physics. You see, the SI unit of mass is kilogram, or short form kg, whereas weight is Newton. Mass is a scalar quantity, whereas weight is a vector quantity. In daily life, we tend to measure weight in kilograms, but in physics, it's actually mass in kilogram and not weight. For example, someone might say, oh, my weight is 45 kilograms. But in physics, we know that weight is not measured in kilograms. It's actually measured in Newton. So technically, the correct way to have expressed it was, my mass is 45 kilograms. So now that's application in daily life. So just remember that in physics, mass is kilograms and weight is in Newton. If you want to be on the safe side, feel free to use the terms mass and weight correctly in daily life, but you might end up confusing a lot of people. Now, other things you need to know about mass is that the value is the same regardless of the gravitational force, whether on Earth, the Moon, or outer space. And that's because mass is a scalar quantity. The direction is not an inherent part of mass. So if that person that we were talking about just now has a mass of 45 kilograms, that person would be 45 kilograms whether on Earth, in the Moon, or even in outer space. Whereas the weight would change because the weight depends on the gravitational force. The greater the gravitational force, the greater the weight. So weight is actually a vector quantity because it has both magnitude and direction, where the direction depends on the direction of the gravitational force. For example, if on Earth, the gravity is pulling us towards the center of the Earth, and that's the direction that the weight is also acting in. So based on what we know about mass and weight, you should of course know that mass is a scalar quantity, while weight is a vector quantity. In addition to knowing all this about mass and weight, you also need to know what measuring instrument is used to measure mass and weight. The measuring instrument used to measure mass is a balance. Now, there are many types of balances, including a triple beam balance and a top pen balance. To be on the safe side, if you're not sure what type of balance to be used, just write balance. Yes, it's accepted in your examinations. So the kind of balance you may have seen in the lab could be something like this. This is a triple beam balance. It's not very commonly used anymore because it is a little bit challenging to use. It is more likely that you would find an electronic balance in your lab. Now, some electronic balances do come with a glass box like this. The purpose of this glass box is to keep any air movement from interfering with the sensitive reading of the electronic balance. However, it is quite possible that in your school lab, you may not have the glass box because it's not really necessary to measure all the different masses. So why these devices are known as a balance is because the measurement of mass actually uses a balancing system inside. You can't see it inside the electronic balance, but it's there. Now, to measure weight. Because weight depends on the gravitational pull, the instrument used just needs to pull the object down and we measure the effect of gravity on that object. So a weighing scale is used to measure weight. In a school lab, it is more common to use a spring balance, also known as a Newton meter. So this is called a spring balance because there's a spring inside. You hang the object you want to measure the weight of from the hook. The hook will pull the spring, causing the needle to move and point to the weight reading. So that's why it's called a spring balance, but it's also more commonly known as a Newton meter because it shows the measurement in Newton. For those of you who are wondering why a Newton meter, the meter here is not referring to the unit for length. It's not like the meters and centimeters and all that. The term meter here refers to a measuring instrument. For example, you see it in ammeter or voltmeter, and in this case, Newton meter. So the relationship between mass and weight can be observed from this equation. So in this equation, W is the weight, M is the mass, G is the value of the gravitational acceleration. Or, depending on the syllabus that you're taking, sometimes G is known as the gravitational field strength. The gravitational acceleration and the gravitational field strength are actually kind of the same thing in this case, and yes, they have the same value. So what is the difference between gravitational acceleration and gravitational field strength? Well, they are related and they do have the same values. It's just that they do mean slightly different things, although they come down to being the same quantity. You see, weight is measured in Newton while mass is measured in kilograms. Gravitational acceleration is a type of acceleration where the unit is meters per second squared. And as you should have learned by now, the value of the gravitational acceleration depends on where we are. For example, on Earth, the value could be 9.8 meters per second squared if you're taking IGCSE, or 9.81 meters per second squared if you're taking SPM, or a similar value depending on your syllabus. But if we are at a higher altitude compared to the surface of the Earth, the value of G could be lower because we're further away from the center of the Earth. Or if you're on the moon, or if you're on another planet, or if you're in outer space, the value of G changes because it depends on the gravitational field strength in those areas. So what is gravitational field strength? Gravitational field strength is quite simply the ratio between the weight and mass, which means it is expressed as Newton per kilogram. How much force is acting on that object based on its mass? The value of the gravitational field strength is exactly the same as the gravitational acceleration. The units may look different, but in the end they come down to the same thing. And another thing to note is that if you look at this formula, you should be able to see that there is a similarity with the formula from Newton's second law of motion, where F equals to ma. So essentially, when you look at this weight formula, you'll find that, yeah, weight is actually a type of force. That's why we measure it in Newton. M, which is mass, is of course the same thing, while A is acceleration, and G is just a type of acceleration. So that's just one thing for you to be aware of when we're understanding more about mass and weight. Now let's just take a look at some quick comparisons of numbers. So we've got Earth, the moon, and a vast empty space. Let's consider that person again with the 45 kilogram of body mass. Alright, so given that the mass of the person is 45 kilograms, let's calculate the weight of this person on Earth, on the moon, and in outer space. We would of course need to know what the value of G is for those different areas. So if I were to solve this for those who are taking IGCSE, we know that G is 9.8 meters per second squared. That means that the weight is 45 times 9.8, which gives us 441 Newton. If you're taking SPM, the method is exactly the same. It's just that the value of G is 9.8 meters per second squared. So the weight would be 45 times 9.81, which gives us 441.45 Newton. So how you calculate it is the same. It just depends on the value of G that's given to you in your examinations. Now let's compare that to the moon. What is the value of G on the moon? Now, if you were asked to calculate the weight of the person or the object on the moon, then the question will have to give you the value of G of the moon. In this case, what we're going to be provided here is that the value of G on the moon is about 1/6 of that of the G of Earth. So if we already know the weight of the person on Earth, then we can just take that value of the weight and multiply it by 1/6. But say we don't have the weight and we have to calculate this separately. So here's how you can do is, we know that W equals mg. So mass of course is 45 and the G value given in IGCSE is 9.8. So we're going to divide it by 6 and you would get 73.5 Newton. You can also do the same thing for SPM, where W equals mg. And again a note, if you already have the weight of the person on Earth calculated here, which is 441.45, you can take that and divide it by 6 straight away. I'm just showing you what if you didn't calculate the weight on Earth, but you were given this value of G of the moon as 1/6. So the correct step-by-step method would be, of course, to work with the formula and substitute the values in correctly. And the answer you should get here is 73.58 Newton. So I'm just going to draw lines here to show these are the values of weight on Earth, depending on whether you're calculating it for IGCSE or SPM, And these are the values of the weight on the moon. Now, if you were asked what about the weight in outer space where it's a vacuum, given that the value of g is 0 because there's no gravity, therefore no gravitational acceleration nor gravitational field strength, obviously anything multiplied with 0 will give us 0. Hence, IGCSE or SPM, the weight will be 0. That means this person or the object will be weightless in outer space. And that is it for this lesson. Do help me keep making free educational video lessons and lab practicals. Donations are welcomed at my Ko-fi page, which is ko-fi.com/physicsrocks. If you'd like access to notes, quizzes, and syllabus updates, do check out my website at physicsrocks.com. If you found this video to be educational and helpful, do subscribe for more free physics lessons by your physics teacher, Ms. Ho. Check out my YouTube channel for other video lessons on topics you might want to learn more about. Happy studying!